Okay, it's 10 a.m. First off, I want to just thank everybody for joining me today. Hope through the course of the next 30 minutes, you'll kind of get an idea of my passion for photoelectric sensors and really what Balluff does with them and how we can solve applications through different product families and all that good stuff. So the backgrounds on this call might be across the board. I'm going to try to keep it pretty fast and furious. I don't plan on digging in too deep into a technology, but my information will be at the end of this presentation. Please feel free to reach out to me, any resources you find on our website. Everybody here at Balluff are more than eager to help. So if there's any follow-up from this, please reach out to me personally. I'd love to have a conversation with you about your application or just answer some questions, dig into a topic you might have found interesting. But today, yeah, we're going to talk about photoelectric sensors, primarily standard and tricky applications. So the thing with photoelectrics is, they are a technology that requires no contact, right? This isn't a mechanical switch. So it uses light, right? So sometimes people don't see photoelectric sensors as a application solution for some applications. Some people just don't use them in the way that they've evolved into. So we'll go over a bunch of this stuff. But again, I appreciate everybody joining, and we'll get rolling. So go into presentation mode so everyone can see my screen a little better. Okay, so what are we going to cover today? A quick overview of technologies. Again, I want to get everybody on the same page, kind of what makes some technologies more unique than others, some standard. We're going to dive into blue light. That's a little more rare in the photoelectric world, and I'll tell you why. We'll highlight contrast sensors, great solution for certain applications. Touch on fork sensors. Okay, I'll let you know what those are here in a minute. Explain SAM sensors. I'll explain the acronym later. We'll do an application lightning round. I'm going to throw 4 or 5 applications at you at the end to kind of show, maybe some applications that were solved with different technologies in the past that they've moved to photoelectrics. A call to action, and that's just really what we do next. And we're going to do this all in 30 minutes or less, kind of like ordering a pizza. So I want to kick this off with a pretty cool marketing piece Balluff just released. We call it the Heroes of Automation. This one focuses on photoelectric sensors. I apologize if there's no audio. Sometimes it plays through, sometimes it doesn't, but I think you'll get the gist. And this is a very short video, just to kind of give you guys an idea of our bandwidth when it comes to photoelectric sensors. While watching this video too, try to start, mentally making some notes in your head, kind of like how you could use photoelectrics differently, how you can use photoelectrics to maybe advance your machine or your application or your process for error proofing or detection or even measurement. This photoelectric you're seeing right here, we're actually going to dive into that family a little bit here in a minute, and I'll explain why later, but that's what we call our 6K family. Super versatile. Okay. Okay, so that was our little promotional video for Heroes of Automation. And again, we're focusing on photoelectrics. We'll be doing another one on some other product families we do, inductive sensors, capacitive sensors, positioning sensors. So look for those, marketing pushes here in the near future. But again, today we're talking about photoelectrics. And specifically, I'm going to focus on the 6K family. And that's just because they're just so versatile. We can dive into every technology, I guess relative to photoelectrics, just in this family. So we can jump in and out of any of these as we need to. So that's why I just thought, let's just stick to one family. Although Balluff has several different families, different shapes, sizes, capabilities, solution focused, application specific family. So please don't think this is our only offering. But again, it's just so versatile. It's so easy to jump in and out. And if you guys can see my camera, I don't know if it's going to pick up or not, but this is a physical 6K photoelectric. So this is a Post-it note I'm holding up in front of my face, and that's the size. And 6K, it refers to a naming strategy Balluff has, and that's basically its size. So it's 6 cubic centimeters. So very tiny. So some of the standard technologies, right? You may have heard of diffuse. That's when you're shooting or emitting a light out of the sensor and it's bouncing off something, not a reflector, just an object, and coming back to a receiver. They're both housed in that same body. That's diffuse. Retroflective, you're bouncing off a reflector. Usually that's a polarized reflector. That's going to allow you to minimize any false reading. So it tilts the light at a 90-degree angle to come back into the receiver in a polarized fashion, not to bounce off something else and maybe like a mirror or a shiny object and get a false trigger. Through beam, very similar to what's in the bottom of your garage door, or, going out of a car wash or something like that. It's just you have a emitter receiver. They both have their own power. What you gain with that is distance, because that light only has to go one way. It doesn't have to bounce off something and come back. It goes straight across into the receiver. You gain a lot of distance with it. And then BGS. BGS stands for background suppression. So that technology comes into play when you have a background. Maybe it's a guardrail or the backing of a conveyor or the inner workings of a machine going on behind the part or the media you're trying to detect, and you don't want to read that. So in essence, you're able to mask out anything going on, behind the object in question. So comes in play a lot in conveyors, and maybe a sensor looking down at a conveyor itself. You can ignore that and then again look for a specific part, or maybe a specific size part. So if the wrong one comes through, it doesn't read because it's not quite tall enough to make the output. Then you have laser technologies. You have basically all the same things a red light does under laser, but the big difference there is time of flight. And we'll touch on time of flight in a little bit, but just want you to know, great for measurement, great for accuracy, and obviously it uses a laser. And then blue light we'll touch on a little bit as well. You'll see underneath that blue light there's a BGS, so that's background suppression again, and there's fixed focus. What's fixed focus is basically you set the sensor up. It's dialed in at the factory to be a certain distance from the target. It's supposed to operate within that range. Not necessarily taught a wide variety of ranges. Then you have distance sensors and like kind of special, we call them, things that aren't maybe standard use type sensors. So distance, great for measurement. Laser is usually the go-to on that. It's a little more accurate. The light's a little more better controlled. And then the other special ones are contrast and color. This actually is a color sensor. And we'll touch on both of those, at least the contrast, a little more detail. But just know the color sensors in this family, you can teach them an array of colors, and it's going to flag your output if your color is present in front of it at the specified distance. So great for, just proper labeling, proper, product based on its color, or, error proofing or quality. So keep in mind. And again, all of these technologies in this little 6 cubic centimeter photoelectric. Okay, so real quick, again, this is just a look at the 6K, but one thing I didn't touch on when I looked at all those technologies is IO-Link. And not to dig too deep into IO-Link, but that's just kind of where the industry's going. Some of you may be familiar with it, some may not, but this is just a great way for ease of programming, setup of sensors, a network type system into your PLC, wherever your control system is, pulling data and setup and diagnostic features from the sensor. So all of these models, in one way, shape, or form anyway, have IO-Link inside. So something else to think about for your application is, do you need extra data? Do you need a network-based hub? So these are compatible with them. We're not going to dig into this too much. I kind of showed you it up close on the camera, but just, there's a push to teach button on this family. That's becoming more common in photoelectric sensors. We're seeing that in a lot of different families, not only internally to Balluff, but, competitors. Push to teach is a much easier way to set up a background suppression sensor than maybe a potentiometer on top. So just, that does have a push to teach. It has a power and a output on off light. Okay, so like I mentioned, we're going to touch on that time of flight technology, right? So time of flight basically is just use a laser, and somebody somehow calculated the speed of light a long time ago. So we know that that's like a given, right? So we basically take that laser, we shoot it out, we hit something, it comes back. And we know that if it's 1 foot away, that light has to travel 2 feet to get back. So we do some math with the speed of light, and we know that it's now 2 feet away based on the time it took that laser to get back. Now, other ways to do this measurement with light is to bounce off the object and it will come back at an angle. Well, then that really limits your range, because you would have to have receivers lined up in a row, and depending on which receiver it tripped was the angle of the light that it came back. So it really minimizes your range and your accuracy. So this is a technology that ups the accuracy, ups the range, gives you a pinpoint style light output for great alignment, great technology. So again, when you hear TOF or TOF or time of flight, that's the difference. It's using math to calculate the distance instead of an angle. Background suppression we touched on a little bit, but we're using blue light in some models, and that's really because the market's needing it. I mean, there's some limitations to red light, and that's where blue light comes in. We will kind of jump past this one. I think the blue one's next, but just so you know, flexibility is key on this. All right, so you see some of them are mounted down at the conveyor. That's probably a background suppression. Some are mounted at a retroreflective. That's probably because you need the range to bridge the gap of that conveyor, right? That other one might be a diffuse, the one in the back there, the red light. That's probably because it needs to trip off of a specific item at a certain distance. So ton of different ways to mount these, to use these based on the technology, and extremely flexible. Red light sensors, these are the kind of like the Swiss Army knife of photoelectrics. You're going to see red, you're going to see infrared, and you're going to see blue. There's kind of your main colors. And the reason being is red just gives you a nice, I guess, kind of universal, reaction to a lot of different colors, a lot of different objects. But where it lacks is it doesn't do great with reflective and clear objects. So that's when there's alternatives. Laser gives you a really nice pinpoint and long range. Sometimes there's more cost involved, but that's the give and take. It's going to give you a pinpoint spot. So say you have a I don't know, hypothetical, you have a machine going down the line with a bunch of holes in it. Well, a laser you might not want to use, because if it goes into one of those holes, it's going to say, oh, I'm not here, if it's just slightly off. And you don't care maybe how accurate it is. Maybe you just need to be in front of something. Just be somewhat in like the vicinity of a couple inches. A standard red light is the way to go, because it's going to give you a larger area to reflect off of because of the spreading out of that light. That light wants to, cone outwards exponentially as it travels through space. So, but laser sensors gives you a pinpoint spot to detect at long ranges. So just be aware, you want to make sure your object is doesn't have any dead areas around it that could possibly give you a false trip or a non-trip. Time of flight, we won't spend much time on, but I just want to point out that in this little small package, we have a time of flight that goes 1.5 meters. So that's pretty cool. And, you get that adjustability of the measurement of nearly that entire 1.5 meters. There's a little bit of a dead zone when you get really close to the sensor. But yeah, you're looking at 1.5 meters of adjustability and measurement. Accurate alignment detection is really what they're good for with a small sensor. I won't spend much time on that. And then we'll jump into blue light. So why blue light, right? So red light's great because it's kind of universal. Well, it also gets absorbed into things very easily, and it burns through things very easily. So with blue light, we found that it works really good with shiny objects and really good with transparent objects. And I'll show you another couple small videos here in a second. And the reason being is it's wavelength, right? Light's just a different, spot on the spectrum of light, the wavelength. So because that wavelength is I guess has characteristics different than red, when it hits stuff like maybe a roll of carpet, it doesn't absorb into it as easily, or maybe a black tire. Also, when it comes to transparent light, it's able to bounce off it instead of burn through it. So you'll see a couple examples here why blue light really has some unique characteristics for tricky applications in the real world. Again, just reiterates what I just said, just likely to pass through, less likely to pass through transparent objects. So again, great for, packaging material, shrink wrap, webbing, stuff like that. So here, I'll see if this video plays as well. If there's music, you can hear it. If not, but keep an eye on these two sensors. So we have a standard red light to the left and a blue light to the right. And you can kind of detect that based off of the light reflecting off the object. Now keep an eye on those outputs. See those little orange lights that turn on? The red light can't get back to it. These are diffuse sensors. Where the blue light, you can detect that packaging, just a few inches away. The red light probably will never pick that up. So that's where the blue light shines, no pun intended, over the red light. So keep that in mind when you're looking at applications. Clear or dense materials usually operate better with a blue light variant of a sensor. And wafer detection, this is a big one. So we see this a lot in wafer detection because they're so shiny. It makes red light, dance around a bit and have a reaction that maybe could false trip or double trip, the output. So it minimizes that interference. And again, there's another small video kind of showing that. This is a very highly reflective piece of metal, and he's going to pass several different objects, a dark object, some stuff, and really kind of manipulate it at different angles to try to get that output to flicker. And just watch that amber light again, that orangish light there. Oh yeah, even a mirror. Yeah, this clear bottle, clear vial, and a black shiny surface. These are all tricky with red light. So again, just kind of keep that in the back of your mind as an asterisk when you're kind of dealing with some of these materials. Like, well, maybe we don't go red. Maybe we go blue or something that might have a better reaction to the surface itself. There's some different variants of the blue light. We won't spend much time on the actual product, models and stuff we have. But one cool thing I want to show, and this is kind of across the board on a lot of our product lines and Photoelectrics. I don't know if any of you on the call ever get frustrated that you got to pick an NPN or PNP. Am I syncing or sourcing? Right? What's my output? The cool thing is these auto detect. It's kind of neat, so you don't even have to pick that anymore on certain models. It'll auto detect your it's essentially your input card, and it'll operate as needed. So I like to point that out. You can get them standard. You can get them PNP, NPN if you got, if you just know that's what you need. But just be aware that there is an auto detect version that's very popular. Okay, so contrast sensors. So when you think contrast sensors, some people think, okay, like I'm just detecting a label. Well, yeah, that's a good example for it, and I'll show you an example of that. But another really good use for it is just speed. I mean, if you have a true contrast, like quote unquote contrast, like a black or a white, and you want to count all the blacks and not the whites, a contrast sensor is great because you can just burn through speed with these. 25 kilohertz, super fast paced applications at a distance. Usually with this type of speed, you're talking something with an amplifier, right? So if speed's a thing, a need in your application, think contrast sensor sometimes, because maybe a standard photoelectric just can't do it because it wants to react different to the different surfaces, where a contrast sensor you can teach it react to this amount of reflectivity of light. So keep that in mind. These have saved the day in a lot of label applications, lid applications, stuff like that. So kind of the unsung hero of speed applications in assembly. bunch of different models. Again, really here you're just picking, are you doing an RGB or a white? So basically you're doing black or white, or you're doing different colors and contrast. And there's different speeds. There's a yeah, so you can do 10K or 25K, right? There's different speeds there. So pick your poison. Okay, really quick on fork sensors. I always like to talk about fork sensors, about tricky applications, because sometimes the target itself isn't tricky, but the environment is, right? So say I had to read these bolts on a conveyor or a feeder. If I put a diffuse sensor there, I don't know. It's kind of tricky. It may or may not work. If it gets bumped at all, it's going to be shooting out into the air, or it's going to be shooting down on the rail. So I want to make sure it's aligned right at it. Now, if I used a through beam that was, one mounted on one side, one on the other side, I have a fail point, because if either of them get kicked out of alignment, I'm in trouble. The cool thing about fork sensors are they're metal casts that U-shaped housing here is metal. You have the emitter and you have a receiver all in one unit, and they come back to one power connection. So that's power and IO. How cool, right? So sometimes the application itself isn't that tricky, but the environment is. So the likelihood of this getting knocked out of alignment is probably a catastrophic, smack of the machine, where any other sensor, a nudge of the machine might throw the sensor out of alignment with a small target. So keep these in mind. Okay, SAM sensors, really quick. Smart automation and monitoring sensors. So again, sometimes it's not the target that's tricky, it's what your company needs from you, right? So what these things are designed to do is to give you environmental and machine data in addition to being a photoelectric sensor. So, I'm just reading a candy bar or something on a conveyor. Great. Other sensors can do that, but these have Ecolab approval, they're washed down, and they come with a ton more benefits. I'll jump to those now right here. So condition monitoring features. This has been a trend in the industry I've seen grow over the years. And inside of this sensor, you not only get stuff like, voltage and current monitoring, the temperature of the sensor itself, operation hours. You can actually tell the last time this thing powered off. Say there's a failure in the middle of the night. You can look at that data and be like, hey, this thing's shut down at 3 a.m. For 2 minutes, then it's fired back up. Why? That data is all in there. But in addition to that, you get inclination. So if the sensor gets knocked out of alignment, humidity, just if that's something you want to monitor in the area of interest, vibration. Sometimes that can tell you if there's a bearing going out down the conveyor. And then an extreme environment status. That's just like, a lot of wind, a lot of noise, a lot of something going on. So these are things that are crucial points of data, especially if you have a photoelectric sensor up in some maze of conveyors at like an Amazon facility. Who wants to crawl up there to see what's going on when this can give you a lot of that, give the eyes and the ears, if you will. Just really quick, we talked about red light, standard red light LED versus laser. Both those technologies are in this style of sensor for us. We call it the 254K family. A little bit bigger than the 6K, but again, comes with a lot more features when it comes to that the condition monitoring. But yeah, now here's the lightning round of applications, because we have 7 minutes left, and I promise 30 minutes or less. So real quick, this is photoelectric shooting up at kind of like a bandage material. This is in the medical industry, just detecting the presence. See that small light? These are diffuse barrel style sensors. Okay, so remember, photoelectrics can come in all different shapes and sizes. Balluff has some in cubical, like I showed you in the 6K. We also had cylindrical. Small space, standard application. They want to burn through that film. They want to bounce off that pad, come back, say something's there, right? Now, a blue light would probably be triggering off the plastic. So just use a standard red light. Automotive industry. In the past, a lot of people have used like linear position and linear transducers to like measure exact quality checks and stuff in an assembly or welding or a process like that. What we've seen a trend go to is using photoelectrics in some of these to detect exact placement, the position of knockout holes, or if a bolt is present or not present before like an automated nut goes on. So again, here's an example of us using a small 6K, taking up very little real estate into a nest and a jig of an assembly station. IO link, right? So you see the IO block down here too. So wiring and connectorization is much easier in these type of assembly stations for quality and just automation needs. Another automotive industry. So this is a get up out of the way type thing. We're using our range to get away from the target to detect if a bearing's in there, a ring clamp's there, everything's needed before we press the bearing, right? So we have 3 different sensors, basically saying what's going on when, and am I clear? Do I have the right part? All that good stuff. And this is air proofing and automating at the same time. This is an end-of-line tester for a gear lever. So this is a gear assembly for automotive manufacturer. And if you can see in this little red circle, and there's a red dot there on the gear shifter, that rod going vertical out of the shift assembly. And we just want to know what position it's in, right? Before we run these tests. And you can see over there's cameras and stuff, and we're doing all kinds of stuff in this test hub. But instead of putting a camera on the other side or putting some type of mechanical switch, we're using a very cost-effective photoelectric sensor. And that's doing the lion's share of the work because of how this test assembly works. It needs that rod in different positions at different times. And again, this is doing air proofing, and I would just say process control all in one with a small photoelectric sensor, where in the past it might be using another camera on the other side. I think actually that's what it did. It replaced a camera mounted on the other side here. So food industry, again, a lot of our sensors are Ecolab approved. They can get on your production floor, no problem with the environment. Just be aware of that. And again, with photoelectrics, it gets up out of the way. We don't touch anything. We're not designed to touch anything. If something is touching it, it's not mounted correctly, but we're good for the environment when it comes to wash down and food industry. Assembly and marking, again, this is where deal a lot with robotics, and again, the photoelectric sensors are just like the bread and butter of automation. It's the it's the nervous system, if you will, of the assembly line, because it's telling you what's going on. This is a application where robots are actually stacking these battery cells into a cell hub to make a large battery, and they basically are just monitoring them with very cost-effective sensors, where before they would use vision and different things like that to air-proof the assembly process. But they found that using photoelectrics is far superior when it comes to cost and reliability. So again, when you're thinking about applications and you just need to know something's there, think photoelectric. Okay, so call to action. So we have about 2 minutes left, and I want everybody on the call to just kind of think photoelectrics when you think air-proofing, part detection, assembly, and think about their capabilities beyond, maybe the old retroflective sensors you've used in the past, or beyond just seeing if a part's there or not. Air proofing is big. Precise measurement and positioning is something we can do with photoelectrics. And of course, like you saw, that contrast and blue light, time of flight, and of course, SAMs with all that extra data you may or may not need. So I encourage you to reach out to me, or any sales engineer you might be dealing with currently, or just come to me, because that's I'd like to talk to you. I love talking about this stuff. I love solving applications. I used to be a controls engineer for several years on a washer and dryer manufacturing floor, and I miss it sometimes. So bring me your application. Give me a little slice of that life again, and let me help you out. But with that, I'm going to wrap it up. If anyone does have questions, please feel free to email me with them, circle back with me, and I'd love to chat. I appreciate everybody. Thank you.